Hello everyone, we are on to the next lecture of alkynes, and in today's lecture we will be discussing about the chemical properties of alkynes. Okay, in the previous video I have completed the preparation of alkynes. Right, now chemical properties. Now chemical properties may first we know that alkynes have multiple bond, so they will undergo addition reaction. Which category of addition reactions they undergo? Electrophilic addition reactions. Electrophilic addition reaction, because they have the pi electrons between two carbon atoms, so that can be given easily to the attacking reagent. So they will undergo electrophilic addition reactions similar to what we have already discussed in alkenes, but only one thing is they will undergo trans addition. Okay, now let's first talk about addition of hydrogen. Addition of hydrogen. This, though we have covered in alkanes, alkane preparation, even in alkyne preparation we have discussed this. Okay, the first, suppose we are talking about alkynes, say ethyne. When you are adding on H2, the reaction occurs in the presence of nickel, platinum, palladium, and since there are two pi bonds, there will be two H2s added on. If you're adding one, you will get first alkene. So when two are being added, to HH and HH will add on, and you will get finally ethane. Now, if you remember in ethene, that is in alkene, we have discussed that from some alkynes, if you want to stop the reaction at alkene, you will have to use Lindlar's catalyst. For that, you can just refer to the preparation of alkenes from alkynes in the previous videos. Right? So this was the first addition reaction. The second addition reaction which we are talking about is addition of halogen. Halogens can be added on to alkynes. So when they are added, so obviously what you will be getting is dihalide. Right? So suppose we are talking about this, and we are carrying out the reaction in the presence of, say, bromine, carbon tetrachloride is required. This is, we have discussed there also, it is a test for unsaturation. It is a test for unsaturation, because reddish brown color of the bromine will disappear when it gets added on to the alkynes. Again, there are two pi bonds, so you can add on two, or in one go you can show one addition and the second one, right? So finally what you will be getting is CH, and you will have Br2, two bromines will add on, single bond, CH and Br2. So what will happen? The reddish brown color of the bromine will disappear, so it is a test for unsaturation. So if one Br2 is added, remember one thing, when one Br2 is added, the first product which you get is CH, you will get a double bond, CH, and this Br and Br will be like this, one bromine here, one bromine here. Actually, if we want, we can write instead of this H this side, this H this side, just to show the first product form will be the trans addition. That is the difference, the alkynes will have. Ethyne, when one bromine adds on, you will get a trans product. Means one bromine this side, another bromine this side. The name is 1,2-dibromoethene. The last product so form, when to this one more Br2 is added. This is the intermediate actually. When one bromine is added, this is the first product. One more bromine will be added on this one, and you will get the last product. This is the second product. So what will be the name in this case? 1,1,2,2-tetrabromoethane. If you are using bromine, this will be the product. If you are using chlorine or iodine, accordingly the products will be changed. But only thing is, remember the order of the reactivity of the halogens is chlorine is most reactive, then is bromine, and the least is iodine. Iodine will be least reactive. This is the order of the reactivity of the halogens. Okay. Now moving on to the addition of hydrogen halide. First thing, remember hydrogen halides addition order is HI is maximum, then HBr, HCl, and the least is HF. Reason, the iodine is largest in size, so HI bond will be the weakest, the bond will break faster. Okay, now how it will add on? Say we are taking ethyne and you want to add say HCl, for example, HCl. So one H will add here, one Cl will add here. What you'll get is CH2, a double bond, CH and Cl. Now still there is a multiple bond. Still there is a one pi and one sigma bond. So one more HCl can add on. One more HCl will add on. Now the first product which is formed is vinyl chloride. Vinyl chloride. This radical CH2 double bond CH is called as vinyl radical. So vinyl chloride. Now when one more HCl is to be added to this vinyl chloride, how are you going to add? You will write H this side or Cl, or H this side and Cl this side. So again, wherever there is a doubt, there is a rule. Markovnikov's rule has to be followed. Markovnikov's rule has to be followed means the negative part will add on to the carbon atom. On the first one will be there because the negative part will add on to the carbon atom having less number of hydrogen. So you will have chlorine added here and H will be added here. So what product you will get is CH3 single bond CHCl2. What is this radical? Ethylidene. This is ethylidene chloride. Otherwise, if you are writing the IUPAC name will be 1,1-dichloroethane. This was 1-chloroethene. 1-chloroethene and 1,1-dichloroethane. This will be the product. Clear? Now, in case you are writing with reference to HBr, accordingly you will get vinyl bromide or ethylidene bromide. Right? Now, suppose I take example of such alkyne which is unsymmetrical alkyne. Say we have taken propyne and we want to add on to this HBr. It will be following Markovnikov's rule. That means the negative part will add on to the carbon atom having less number of hydrogens. So you will have CH3 here, C double bond, CH2 and you will get Br here. Still there is unsaturation, so one more HBr can add on. Again the next HBr will add on as per Markovnikov's rule. You will have H here and Br here. So when you add on, what product you will get is CH3, C, here you will have one Br, one more Br will be added here and this will become CH3. So it will be 2,2-dibromopropane and the first, this one, if you are writing the IUPAC name, it is 2-bromo-prop-1-ene. Propene also you can write down. It's one and the same thing. Right? Now, suppose you are asked like this. CH3, C, triple bond, CH. It's a propyne. And suppose you are asked add HBr in the presence of peroxide. In the presence of peroxide you want to add HBr. Then it will follow anti-Markovnikov's rule. Anti-Markovnikov's rule. That means the Br will add on to the carbon having more number of hydrogen atoms. So you will get CH3, CH, double bond, CH, Br. One more HBr can added on. Again in the presence of peroxide. Again it's going to follow anti-Markovnikov. So H here, Br here. So what you will get is CH3, CH2, CH, Br2. This will be the product. That we have already done in alkenes, that HBr addition in the presence of peroxide. In that case only you will have anti-Markovnikov's rule. Otherwise you will not have. You will get the Markovnikov's addition if peroxide is not specified. Yeah, moving on to the another addition of water. So suppose we are considering ethyne and water is to be added on. The reaction occurs in the presence of HgSO4, H2SO4 and 60 degrees Celsius. You can write in Kelvin, it will be 333 or 60 degrees Celsius. So this is a symmetrical alkyne. So when symmetrical alkyne, H, OH, either way it is the same thing. So you will have CH2 double bond CHOH. You will get this product. This is vinyl alcohol. I just now told you what is vinyl radical. CH2 double bond CH is vinyl. So vinyl and alcohol. This is a very unstable product. This is very unstable, so this will undergo tautomerism. It will undergo tautomerism or enol isomerism. It's also referred to as enol isomerism. So in that what happens is, so this H from here will go to the carbon atom just adjacent one to which it is attached. This OH was attached to this carbon atom. So from here the H goes to the carbon atom, the other carbon atom where the double bond is present in between the two. So when this goes here, the valency of the carbon gets disturbed. So the pi bond shifts here and makes this a double bond. So what you get, the rearranged product, that is CH3, CH, and between carbon and oxygen there is a double bond. That means what you get is acetaldehyde. Acetaldehyde. It's ethanol which is obtained. It's very stable product. It's basically, the reaction is hydration of alkynes. You're adding water. For addition of water, this was required. Acid medium was required. Now, in case of, you are having some unsymmetrical alkyne, for example, CH3, C triple bond CH. You have some unsymmetrical alkyne. If you use unsymmetrical alkyne and water is to be added in the acid medium, the reaction is of course the same thing in the presence of HgSO4. 60 degrees Celsius, every condition is important. So when water is to be added to the unsymmetrical alkyne, it will add on as per Markovnikov's rule. The negative part will add on to the carbon atom having less number of hydrogens, and the hydrogen will, the positive part will add on to the carbon having more number. So you will get this CH3, C, now a double bond, CH2, and you will have OH here. Even this is not stable product. This is not stable. So again, it will undergo tautomerism. These are the two carbon atoms bearing double bond. So OH is present here. From here H will go to the carbon, the other carbon atom, not the one where it is already present. So when this goes here, the valency of this carbon is disturbed. So H from here, the pi bond will shift this side between carbon and oxygen. So what you get? CH3, C double bond, C, CH3. Okay, so this is acetone. Acetone. In case you're asked, how do you convert ethyne to ethanol? You can take this reaction. How will you convert propine to acetone? You can use this reaction. Fine? Yeah, moving on to the next reaction of alkynes, that is acidic nature. Acidic nature of alkynes. And particularly this is applicable for terminal alkynes. Terminal alkyne. Terminal alkynes are acidic in nature. Right. Now, why alkynes are acidic in nature? That depends upon the hybridization. Suppose I write CH triple bond CH. This is ethyne. You write down CH2 double bond CH2. This is ethene. CH3 single bond CH3. This is ethane. Now, if you see the carbon atom which is having hydrogen, this is sp hybridized. This is also sp hybridized, sp2 hybridized. Both are sp2. This is sp3 hybridized. We know that sp hybridized carbon is having more electronegativity. It has more electronegativity. So more the electronegativity of the carbon atom which is bearing the hydrogen atom, more will be the acidic nature. Okay. Now why it is so? Because this hydrogen is attached to the carbon atom which is more electronegative. So if I open up this and write down carbon atom like this, it is attached, say, So this is more electronegative. So what it will do? This is going to pull electrons toward itself. As a result, this will get more negative. H will be less tightly held towards the carbon. H will be less tightly held toward the carbon means it can be removed as a proton. It can be removed easily as a proton by a strong base. If suppose this is reacting with some strong base, this H can be replaced very easily by the base as a proton. Okay, so the acidic nature can also be compared to, on the basis of their Ka values, the dissociation constant values. So if you compare that, the acidic nature, the Ka value for this, the first, that is ethyne, is something of the order of 10 to the power minus 25. This is the Ka value, the dissociation constant value. For ethene, the dissociation constant value is 10 to the power minus 35. And this is 10 to the power minus 40. So we know that higher the Ka value, stronger is the acidic nature. So what do you know? That this is more acidic, then ethyne is most acidic, then ethene, and ethane is least acidic. Okay, so you can have, you can prove that these terminal alkynes are acidic in nature because you can carry out a reaction. You can have this, say, for example, ethyne. You can treat this ethyne with sodium. You can have with sodium or with soda amide. So when you are heating in the presence of sodium, what will happen is this H comes out because this will ionize as minus and plus. Na will take the place. So what you will have is CH triple bond CNA. And that H2 will come out as a gas. So H2 is liberated. Now what is this obtained called? This is minus and this is plus. This is ion of ethyne. So it is called as ethynide because one sodium is there. So the name can be written as monosodium ethynide. Monosodium ethynide. Instead of ethynide, you may also write acetylide. So monosodium acetylide, that can be the name of this. Suppose you carry out the reaction of this with another one, say CH triple bond CNA. You carry out its reaction with one more sodium. So one more sodium will come this side. So this will go away and you will have NaC triple bond CNA. Plus one more H2 will come out. That means the name of this product is disodium acetylide. Disodium acetylide, or you can write ethynide. Okay. The similar reaction you can also carry out with the soda amide. Say suppose you are having RC triple bond CH and you are carrying out the reaction with NaNH2. The reaction has to be in the presence of liquid ammonia and heating. So what you'll get is this H will come out. You will have R, C, triple bond, C, Na and NH2 will be obtained. Now there is only one NaNH2 which is going to attack in this case because this is a terminal alkyne. So terminal alkynes only have H. If it is somewhere in the center, then you cannot have this test. Okay, so suppose you are asked a question, how will you distinguish between but 1 ion and but 2 ion? Like this. Suppose you have but 1 ion and but 2 ion. You can write down the reaction with sodium. You can write reaction with sodium. Why? Because this is a terminal alkyne. It can react with sodium. This will not react with sodium. So if it is made to react with sodium, what will be the product? It will form CH3, CH2, C, triple bond, C, Na plus hydrogen gas will be liberated. So this is going to react with it. Okay, the same reaction you can use. Suppose you are asked, how are you going to distinguish between a very important question? Suppose you are asked, how will you distinguish between ethene and ethyne? Then too you will write down reaction with sodium. Ethyne will react with sodium, this will not react. So you can use this test. You will write this is reacting and also write down the equation which I told you here in the beginning. Okay, suppose you are asked the same thing, can you use that bromine water test? No, because bromine water test is the test for unsaturation, which both ethene and ethyne will give this as a positive test. And okay, suppose you are asked how will you distinguish between ethene and benzene? Then you can have that bromine water test, bromine and carbon tetrachloride. This will give as a positive test, benzene will not give. Benzene, though it is having a multiple bond, will not give that unsaturation test of bromine water because the double bond position is not fixed. It is in resonance. Okay. Last very important reaction of alkyne, that is polymerization. Polymerization of ethyne. So it is a very, very important test, useful in lot of conversions. So what happens is 3 molecules of ethyne, when they are passed through red hot iron or copper tube, they will undergo cyclic, trimerization or coupling, we can say. So what exactly happens is, let me write down 3 ethynes in this manner. The second one, and let me write the third one here. So when they are undergoing polymerization, one of the pi bond from here shifts this side, another pi bond this side, this pi bond shift this side. So let us write now the final product. What you will get? This will be CH. Let me write all CH first. And this is 5th one. Now this becomes a double bond. Single bond appears, double bond, a single bond, double bond and single bond. What is this? Benzene. You will get benzene as the product. Benzene is the product obtained. Right? So in some conversions, if benzene is to be prepared and then further you want to carry out some reactions, you can use this. Let us take one practice question. Suppose you have this propine and you are asked to carry out the reaction in the presence of red hot iron tube. What will be the product? You can just try writing on your own. This part is same, only one alkyl part, methyl part is extra. So what you'll get is, you'll get one methyl here. I'm just writing in this only now. One methyl here, third methyl here. So instead of benzene now, what you will get is mesitylene. Mesitylene, that will be the product. Benzene is with ethyne, and if you use propine, what you'll get is, in this only I have written the product. This was for ethyne only. Now this will be the product, that is mesitylene. Alternately, you will have 3 alkyl radicals. With this, we complete alkynes. Okay, so please practice this one. And in the next video, I will be completing benzene. So with that, the hydrocarbon will be done. Thank you.